Okay. Hello to all of my ninth graders, as well as I guess my parents who are unfortunately having to learn the Calvin cycle due to your child having a test on it, and you probably not remembering anything about it from high school and college. So I'm going to be as quick and brief as I can about this. I'm just going to give you what you need to know on my test for full credit. Again, parents, as I said before, every test has major concepts, and this test has one major concept, and it is the dark cycle, the dark reaction, the Calvin cycle, as we would call it, of photosynthesis. So what is expected of them is basically 40% of their grade. I need a regurgitation of the drawing that exists for this cycle, and then I expect to see some information regarding what happened. They can do so in a sentence, shorthand form, does not matter to me. It just doesn't have to be some kind of major production, but it can't be, I don't know what's happening and I didn't care to learn it. Okay, it's just that simple. I've been over this with them for now 3 days. We spent last week, Monday and Tuesday on this. They have been quizzed on this. I've had many that have not done well on these quizzes, and it's because the Calvin cycle is difficult. And because it's difficult, we have this tendency to shut down, and it's not helping them. That's all I can tell you. They've got to get to the point, and I heart with them every day, about realizing that the things that do matter in this world are difficult, and that's just the reality of it. And so I'm going to provide this video so that there is zero questions as to what's being expected, but most importantly, so that you can help this study versus your child feeling like they're on their own, having to try to learn the Calvin cycle. They shouldn't have been on their own anyway, because I was there teaching that material to them over the past 3 days. They'll probably get another day tomorrow of some form of a review regarding this before our test. And we did a review today, and I gave them a Calvin cycle drawing that was partially filled in, and we had some do well, and we had a bunch that did not. Part of that is because I think they still think that pop quizzes are only allowed to happen when I tell them to prepare for this thing. Granted, today wasn't even a pop quiz, because yesterday I told them to realize they probably needed to know that drawing before they showed up at class today. So anyway, let's get over this real quick, okay? So Calvin cycle. Here's our drawing, okay? Shouldn't be anything major. I'm going to try my best to draw Calvin cycle here, and I'm going to give you some words over here. My handwriting's terrible. If you have to, just replay what I've said. That will probably help you out versus what I'm trying to write. But here we go. I'm going to give you the drawing. This is what's expected of them. CO2 is brought into our cycle to join a molecule called RUBP. I've told them they only have to know RUBP. It does not matter that they know anything else about it. Just give me RUBP and they're fine. Okay? This is going to form a 6-carbon molecule. Okay? That's what it's going to form. It's a 6-carbon molecule. That 6-carbon molecule is going to break into 2 PGAs. 2. It's vital that we put 2 down. A PGA is a 3-carbon molecule. You can't just make 3 carbons disappear. It doesn't work that way. These 2 PGAs are going to become 2 G3Ps, but they require something. The students know that PGA is boring. Their father watches it and goes to sleep on the couch, and they don't want to. And it needs to be energetic. So to create this opportunity to make an energetic molecule, we have to introduce energy, which they should know comes from the light reaction itself. That is ATP and NADPH. Those require 2 of each. ATP, 2 of them are converted to 2 ADPs. 2 NADPHs are converted to 2 NADP+. I've told them I do not even need them to understand what these things even stand for. Just memorize literally the letters associated with it and be done. There's only one last step to this cycle. That is these 2 G3Ps. They are going to deliver a single carbon, which will eventually form glucose. The 5 remaining are going to reform RUBP with the help of one ATP becoming an ADP. The cycle continues for every carbon dioxide that's brought in. They know that it takes 6 cycles of the Calvin cycle to form one glucose molecule. It costs them 18 ATPs and 12 NADPHs. And that's because there's 2 ATPs here, there's 1 here. That's 3. But this cycle has to happen 6 times to make a single glucose molecule. 6 times 3 is 18. There's only 2 NADHs. 6 times 2 is 12. End result of this, right, is 18 ATPs, 12 NADHs that it cost to make one glucose molecule was the ultimate plan for what the Calvin cycle does. This is the Calvin cycle. This is what they're expected to draw from me on this test. Then they're expected to give me some information, and I'm going to see if I can move us slightly, maybe slightly closer over. They're expected to give me some information on what's going on, okay? Let me go back because I did not do this. My kids are all yelling at me if they're watching this video. So this step is called carbon fixation, okay? This step of energizing this molecule, step 2, is called reduction. And this step that's over here, where we reform RUBP, is called regeneration. Sorry I wrote that in between there. I know that's a little confusing, okay? Those are those 3 steps. So what I want them to now do is I want them to give me a bullet point of this, of what happened, okay? So I'm going to give you my version of bullet point. I'd give you full credit, okay, for this being put down there, okay? If we can. We'll make sure I can still see. So CO2 binds to RUBP, okay, to make a 6-carbon molecule. If they were to have drawn everything else up here, and they were to put a 1 here in a line, it tells me that they know that carbon fixation, which is this 1, if they were to give me this, that this is the first step. That's all they're telling me. This is what happened, carbon fixation. The carbon from the CO2 bonds with a 5-carbon RUBP to give me a 6-carbon molecule. That's what they told me. That lets me know that they did more than just memorize a drawing. That doesn't do much for me, okay? So there's our first thing. Let's now go to the next step, if we will, from PGA to here, okay? So what's going to happen is that our 6-carbon molecule is going to split into 2 PGAs. 2 PGAs will become 2 G3Ps with the help of energy. Step number 2. Again, handwriting, I know, okay? I know you're far away. I'm not trying to do this on the computer and pull it up. Very simply, all they were telling me is that this 6-carbon molecule had to become these 2 G3Ps, and how? They split into 2 PGAs. We added energy to make 2 G3Ps. Do not care how that's worded. Again, this is shorthand. This is not even sentences, and I'm perfectly fine with this. You can write it out in a sentence and a paragraph form, it's fine. But you got to be able to give me some conceptual ideas that you know what's really happening in this cycle, okay? Last step, what are we doing? We're going from here back to here, and they know this is regeneration. So very simply, there's not a whole lot going to go on here. It's going to be that these 2 G3Ps, we are going to have 1 carbon. Let's put saved here instead of lost, okay? One carbon is going to be safe. We're going to build glucose. Remember, we got to do one carbon at a time. Takes 6 times. Of course, carbon, they know very well that glucose is C6, right? 6 carbons is what it takes. So we save 1 carbon, and we're going to use 5 carbons to rebuild RUBP with help of energy. This step is step 3. I'm going to draw us a separator, okay? There. The last thing that I need them to tell me on this entire write-up is, can they tell me what the ultimate purpose of this process was and what we would have gotten? Well, we just wrote it up here. So the ultimate purpose is that after this is done, after 6 cycles, right? So I'm going to try to write this. Maybe down here I'll move us. After 6 cycles, we get 1 glucose molecule. Cost 18 ATPs, 12 NADPHs. The end. I know everything that I'm showing you right now, and I'm going to try to get this as close as I can. I know that everything that I'm showing you right now looks like an absolute mess. And I'm sure there's parents that probably have turned off their brains like some of my children have done over the last few days in this class, and I get you. But as I have told them, if they have written and rewritten this on a blank piece of paper a few times, they can basically give me that information over there with really no major effort, because they know the 3 steps and all they're doing is regurgitating that to me. Okay? So, again, this is a major part of their test. This is, again, the Calvin cycle. And I'm prepping us, moms and dads, etc. I'm prepping us. This is the beginning. Next week, we have, and this week actually, as we begin, we have cellular respiration. We're about to get into talking about glycolysis and pyruvate oxidation and the joys that is the Krebs cycle. The Krebs cycle is 9 steps of lots of words they don't know. The moment that I give it to them, as parents, you should ask them, come home and draw it. Come home and draw it. Every day. Once they've drawn it 3 or 4 times, they may forget it by the end of the year. I got you. But they're going to understand some concepts when they see me for dual enrollment biology or whatever else it is. They won't be completely lost. Okay? But I can tell you, if they write it down every day for the next 5 days, they're going to be fine on my test. And that is a huge 50% of our test for our next test in cellular respiration. It's all about those 4 steps for cellular respiration. So, again, this is DART reaction. This is what we define as the Calvin cycle. And I've pretty much laid out in front of you everything you could possibly need to know about it for this test. So, rewatch the video, draw, redraw. Hopefully, Lord willing, we will be A-okay on this test. Test is Thursday. This is Tuesday when I'm making this video. So you got at least 48 hours to watch and rewatch this joker, or roughly at least up to that point. Okay? All right, thank you very much.